hot up in here. Yeah, we're live. It is 6:03, so I'm coming to you early. I got something I got to be to after 7, so I've got to get going. But tonight we're going to talk about the oiling system mods video that I just posted. Is on small block Ford stuff, and what I did is I ran two different motors. One of them was a 347, so the 8.2 deck. This was with a 5-liter, at the time, late model hydraulic roller block. So we made a 347 out of that. We put scat stuff in it and pistons and things and excuse me, and then ran the stock pan, which we know fits. That's what you can say about the stock 5-liter pan. It does fit, and you can paint it, I guess, is another good thing. And it allows you to run the sensors, the oil level sensors and things that are in there. But it's not great. It's certainly not from a performance standpoint. But what I did was show what happens. We did, head cam and intake manifold on it and did your typical kind of build up for the small block Ford. But then we did a pan swap. So we did the Mylodon pan with the integrated windage tray and a kick out and that kind of stuff, even though the photo that I'm showing is with a pan and a separate windage tray. That's because I've also run those, but I didn't do a back-to-back test on that one, at least not on this 347. So I also did the same thing with the same type of pan, a deep sump kick-out pan with an integrated windage tray on the 351 based 427 stroker with the dart block. That one took a little bit more work because we had to do some trimming here and there to make the pan work on that 427 because it was a 4-bolt main block. And I don't think that this pan was designed to work with that particular block. We made it work. You got to do what you got to do. So that pan, in addition to the kick out and the integrated windage tray, obviously had more capacity. And it also had, you saw on the side, if you've watched the video, you can see on the side where the kick out is, there's also crank scrapers. We didn't get in and lengthen them or do anything to get them exactly, where the rods are going through and stuff. But it is better than not having anything there. And so if you want to get real precise on your crank scrapers, you can go in and do that. Again, you're just trying to shed the oil off as it comes around and get the oil to just run back down into the pan and not carry up and load the crank up and stop basically, think about putting big weights on there. Like, that crank doesn't want to spin. Well, oil is like that. I mean, to a lesser extent because it's not very weighty. But when you're spinning stuff really, really fast, the relativistic mass becomes very important. And what happens is the upshot is that if you can get rid of that, you can definitely pick up power. And that's what we showed. That was what we showed on both these motors. It was 10 to 12 horsepower on both of them. And actually, we did, after doing the testing on this 427, I did a similar upgrade on my Engine Masters motor, and we saw even more power on that. And for the Engine Masters motor, which was a 410-inch motor, we were running about the same RPM. I think 7,000 RPM was our window in there. But what we were looking at was average power production. So we were looking at average power and average torque. I think, if I remember right, from 2,500 to 7,000 or something. And so we were concerned with all the power production through that whole range. So the average power, the average torque, added up and then divided by 2 was basically our score for Engine Masters. And so you wanted to do everything that you could in that range. And so you're not picking a cam that's just going to make really big power up top or down low or whatever. You need a good average one. And the oiling system mods was a good add for this because we did pick up a reasonable amount of power, and it was definitely beneficial. I mean, I think that there's more that could have been done I didn't do a lot of or any channeling the oil for the drains to make it go. You want it to drain, basically. You could put troughs there and drain it so that it doesn't come back down on the camshaft or the crank. That's a good idea because you want to get rid of that. That's just lost power. As long as you have enough oiling to everything, you don't want to have too much, and then that's very important. That's the deal with the oil system. And it'd be interesting. One of the things I've wanted to do for a long time is make a clear pan so that we could see what all is going in there. I don't know how well we'd be able to see given the chaos that's happening there, but it'd be something that would be cool. It'd definitely be worth a try to see if we could see all of the chaos that's happening while the thing is running. Could make it out of clear lucite or something and glue it. I mean, it'd stay there if you drilled it and bolted in place or whatever, it'd be there long enough for you to get some video at least and kind of see what's going on. And then you could see what's happening with a regular windage tray or with a regular pan, and then with a kick out pan and, windage tray. That all would be really, really, really cool data. Just take some finagling with some, something that you could see through, so you could see into the chaos. It'd be kind of cool. But the oiling system is not normally places where people look for power. The exception to that might be road race guys. They tend to be concerned about that because they're concerned more with making sure that they continue to have oil with the lateral G's and the side loading that they're getting and stuff, especially if they're out on bankings and stuff. You got to, a dry sump obviously is the ultimate way to make sure that you have that. Much better than most wet sump systems, but it becomes pretty pricey. So there's definitely power to be had from modifying the oiling system. And one of the things I talked about in the video is that there's also longevity. You want to make sure that you get oil. You want to make sure that you don't get oil that's aerated, and this becomes a problem, especially with hydraulic stuff, hydraulic actuated cams, hydraulic flat tap and stuff, or hydraulic roller. Aerated oil is not good. It can upset the function of the lifter. It doesn't do that on solid stuff because there's nothing in there, but on hydraulic stuff, that has been known to cause some problems and repeatability issues and stuff. And especially at higher engine speeds, that can become problematic when the oil gets more and more foamy. So that can become a problem. Let me know if you guys have seen the video. And if not, please go take a look. We got to get our poll going. So have you guys ever upgraded your oiling system on any motor that you've worked on? Car, boat, truck, plane, whatever? Ask your community, and they shall answer. And the answer was good. Yo! We got a lot of yo's and yo-yos and stuff going on there. I have a 2000 GMC K3500, so the big boy, 454. Could I do an Edelbrock RPM head cam intake and carburetor and still have a good daily driver? Yes, depends on the camshaft that you pick. Edelbrock has some bigger cams, so I would pick the RPM cam. Check and see how big it is for that. But you want for a 454 for a daily driver, you want something that's probably going to be 224 or less for a daily driver. Matt, we're waiting. Banks made a clear diff cover. I've seen that. We do that with a big block. We've done oiling system mods on a big block, and it's definitely beneficial. And it's even more so on we get power from big blocks just by changing the oil level pretty dramatically, because big blocks are, especially stroker big blocks, are very susceptible in the dyno to windage issues. And so oil control issues and oil pressure issues on big blocks is a big thing on the engine dyno. So we try to make sure that that's not the case. So definitely a good pan, like we did here, a kick out, windage tray, all that stuff on the big block, always a good idea. I'm unzipped. There are oil pan and valve covers will be something different. I've seen clear valve covers before on small block Chevys. The valve cover thing, we can try. That's not to me as exciting as doing the oil pan. But you can see the rockers going up and down and stuff. What about windage tray screens? Yeah, you can. I talked about that in the video, that there are different types of windage trays. There are louvered ones and screen ones, and you guys can argue back and forth. It's just like the big thing is having a windage tray versus not having one, and then you can nitpick about whether the screen works better than louvers. What about a dumpster fire cam from Texas Speed? I've never tested that camshaft, so if you tell me the specs are, I can tell you what it'll do, though. Yes, on the Sentra, and will be on the small block Chevy. They're a good idea. I mean, that's one of the reasons that an LS does as well as it does, is because it has a factory windage tray, and small block Chevys do not, or the vast majority of them, the factory ones. Every demolition derby engine I build, I modify the oiling system. That's a good idea. Those are subjected to loads. How close do the scrapers have to be to the crank so that they don't hit? Because they will vibrate depending on how thick the metal is and stuff. You just don't want them to hit. You don't want them to touch. I hope the Summit Stage 1 Ghost Cam will be good for daily driver. It will be. Have you boosted a 2014 4.3 liter V6 like the LV3 or the LV1? Is that the one you're talking about? Like the video that I posted yesterday? I haven't run boost on that yet, but we plan to. I remember reading Mopar books in the 90s. That's why they added windage trays on the 360 back then. And I plan on doing one for the 2.2 liter Dodge too. Yeah, the LV3, we haven't run boost on it yet, but we plan to. Because they all need boost, right? Where's our poll at? So we're getting like 7 out of 10 people saying that they've done. Have they taken a look at that? Only after it seems like only after you either see a video on it or have tested it yourself that you stand up and take notice on stuff like that. They're like, oh yeah, that's I was out doing donuts in my car and stuff, and all the oil went away from my pickup. That happens. And so you realize that, hey, if I can make sure that I keep oil in there and keep the pickup covered up with oil, that's a good thing. So you want to enhance drain back. And then once you drain it back, you want to keep it in there and stop it from sloshing around. A lot of OEMs, like the 5 liter Ford, is a good example. It's a big open pan. I mean, that doesn't stop from sloshing around at all. So that's not a good idea. What about the dog bones in the LS motor? We don't replace those normally on junkyard motors when we run them. We take it out and we clean everything, put it back in, if we clean it at all. But normally we take them apart, put ring gap in them. But I put the stock one back in as long as the O-ring's still in good shape. Or if you put a new one in, we just go get one from Brian Tooley, or everybody sells them. They're probably GM ones. We just put those in. I've seen some fancy billet ones. There's not enough load on that for that thing ever to break. I've never seen a broken one in any of the 200,000 or 300,000 mile motors that I take apart. That's never an issue. But it is cool that you can say, oh, I got a billet dog bone, because we know that that's got to be worth at least 20 horsepower, right? All they need is boost. That's the pole's up there, yo. We swapped out an Aviad front sump road race 7-quart and installed an Aviad 3-stage dry sump. Yep. Changed to Detroit Speed aluminum frame suspension. 430 made 716 with the wet sump. We never redownered it. That's a lot of power. That's a good motor. But if you're road racing it, a dry sump oiling system is definitely the way to go. It's in every way better. What about a lifter valley screen? No, people put lifter valley screens in not for windage. People put lifter valley screens in so if a rocker breaks, that doesn't drop the needle bearings down into the motor. I'm going to put a set of entry-level aluminum heads and a cam on a stock 302. Have an air gap intake. Yeah, there are a couple of them. Skip White has them. Summit has them. And Airflow Research has their enforcer heads. All of those are good choices. And then you can look for an inexpensive cam if somebody has one of those. I like that 274 Extreme Energy or something like that. TrickFlow makes a version of that. Want to put a windage tree on my Mopar 360. When I rotated the engine over, it didn't hit, but after I started it, it hit, so I took it out. The truck oil pan and drag racing, it was no problem. Oh, okay, so why would it hit when you rotated the engine? Why did it hit when it was running? Was something not tightened before or something? How about an L8T with a 3-liter Whipple? Would you change the cam? I don't know. I don't know how much power you're looking for. And I have no idea what the stock cam is on an L8T. I've never run one of those. Isn't that is an L8T, is that that's a, let's see. I think that's an LT base motor, right? Gen 5 small block direct injection. So do you have enough fuel for the Whipple supercharger? That's something you might, a problem you might run into with putting a cam in it. So if you put a cam in and you gained 100 horsepower or something with a blower, even if you only gain somewhere between 50 and 100 probably, the boost would come down and the power would go up, but you need more fuel. So will you have enough fuel to do that? What are you thinking about the new Engine Masters oil weight tests? 2050 was better than lighter oil. I think that they need to go revisit their test because I've never seen that ever happen. Dry sump question. Have you had any experience with a 1.5 semi-dry sump? Are you talking about the LS7, the factory LS7 stuff? I think it was made of thin metal and it flexed and just hit the crank. It probably would have clearance itself. I know, but having a noise like that down there is not good. That's never fun. Because then you think, so something's definitely coming apart, right? And you don't want to be shaving metal parts into there too, because if it's hitting, it's definitely taking. If it's clearancing itself, all that clearance stuff has to go somewhere, and it's usually not a good place. .430 Windsor is my '68 Falcon. Oh, that's a good one. But locally in Sassoon by CSM Racing. I've heard of those guys. You'll have updates on the channel. Okay, cool. Taking a couple years. Yeah, projects are always time consuming. So we're at 66 and 34. So 2/3, is that right? Yeah. 2/3 of the peeps. The guys at West Tech have run the dry sump stuff. They have a couple of customers that are LS guys that bring over like LS7 base motors, and a lot of them have that semi-dry sump that an LS7 is. It's not actually a dry sump, not like a racing dry sump, but they have those, and so they have to use the big reservoir and stuff on those. But they work. I have a 430 LSX planning and boosting it. What's the max power you think I can make reliably? There's no way to answer that because I have no idea what you did to the motor or what you plan to do with the motor. If you put a pair of 1,500 horsepower turbos on it, then you can make 3,000 horsepower. But you probably don't have a 3,000 horsepower motor. So I have no idea what that combination is, how well it was put together, what it will withstand. But if you're daily driving it, and I don't know, are you drag racing it for reliability, or are you daily driving it for reliability? So we need more information. Is running an oil cooler and Accusant overkill, or would a baffled pan and an Accusant, would it deem the Accusant unnecessary? It may or may not. I don't know how you're outloading the car. If you're just drag racing, it's probably an Accusant's probably not necessary. If you're road racing the car, then an Accusant's probably not a bad idea. And even if you never end up using it, it can be beneficial at the time when you need it most. But having a good oiling system that does what you need it to do without relying on the Accusant, I think, is a better way to go. But the oil cooler is irrespective of any of these things, because the oil cooler is just going to keep oil temperature at some realistic level, hopefully. It's been hard to find an unmolested 71 to 74 LA360 block. Yeah, I don't see a lot of those in the wrecking yards. Not a lot of LA blocks. I have a small block Chevy and gasoline. How much horsepower do I have? Run the baffle panel along with the Accusant. Yeah, the Accusant is there when you need it, and it's unobtrusive. It's not doing anything when you're not using it. Victor, it's not a daily driver. I don't know. There are guys with 427s that are drag racing that make 2,500, but I don't know that you need that doing what you're doing. I don't know how much power you want. Richard, is knife edging or bull nosing the counterweights on a big block Chevy Connect running at 6,000 or less any benefit? I'd say that there's always benefit from that, but there's less at lower engine speeds. And if you have a motor that you're only running to 6,000 RPM, that's not somewhere where I would be looking for power. There's way too many other places where big gains would get, and especially for the time and money spent doing that. What's my favorite oil temperature? Is there a limit on compression running turbos? There's a limit on compression with running turbos and some given octane. So the octane is going to be the thing. But then there are other things too, like the octane is going to correspond also to whatever you did to your chamber and piston design. And also, what is the temperature of the air going into the motor? There's a lot of stuff, a lot. A 427 at 1,100 horsepower, that's pretty easy to do. 1,100 would be a lot. I don't know what it's in. Is it in a Corvette or something? Then it's gonna kind of, it'll be fast. Yes, oil filters should have capacity. I do agree with that. Has anybody ever run the screen type OBird filters? I don't know. Somebody else probably makes those now too, but they were the first ones that I saw. Has anybody ever run any of those? The replaceable, not the cleanable screens, so you could see all the bearing material when you take it apart? Yeah, C6 with 1,100, especially if it's 1,100 from a turbo or turbos. If it's 1,100 from a centrifugal blower, it's going to be different than it is 1,100 from a turbo. So 1,100 from a turbo, first of all, is going to come at a lower boost level, but also it's going to have a lot more like pull in the RPM range that you're going to be using it on a roll race. Drag ban, I'll see you later. A windage tray is also beneficial, as we saw here. Look at the results of the video. We had windage gains at 3,000 RPM, so all the way past 6,000. So there are gains at that engine speed, and we see gains when we get the oiling system right on big block Chevys. way below 6,000. Where did these esoteric questions come from? Will a 114 lobe separation angle cam reduce raw gasoline fumes out the exhaust since it reduces valve overlap? But did it reduce valve overlap? What are the rest of the things that are happening there? Is it a 114 on a 286, 292 cam? There, yeah. I don't think raw gasoline is going out your exhaust. Do you have any combination that surprises you on the dyno? I'm trying to think. That little Ford crate motor that made over 500 was a little surprising, but I shouldn't have been because it was rated at that by Ford. But we don't see too many 331s that make over 500 horsepower. But this thing had, I didn't expect that as a crate motor from Ford, but it had a giant camshaft and it had lots of static compression and it had a reasonably good Z head on it. That one was a little bit surprising. I like how Steve Morse has a see-through filters. I'm going with Pro Charger. I was worried about bore size being thin at 4135. Thanks for the reply. This is an LSX block. A 4135 on an LSX block is not a problem. A 4135, is it a sleeved block or something, or is it actually an LSX block that will go 4200? 11-to-1 pump gas turbo. I don't know why you would do that. If you're building a motor, there's no reason to have 11-to-1 for a pump gas turbo motor. That's you've just narrowed your tuning window to this big. It doesn't make any sense. And you have to strip all the timing out of it to make it work. 12-to-1 on E85 is maybe a better choice, but again, I don't know why. Why are you looking for power in the danger zone? Is a 268, 272 cam a 50 number or is it an advertised number? Yeah, Victor, I don't think you have to worry about that. If I was running boost, I wouldn't worry about having a big bore, but if it's already done, it's done, then just run that. Yeah, it definitely is in the danger zone. Even Tom Cruise wouldn't go there. Oh, so that's an advertised number. So that's a tiny camshaft. Yeah, you're not going to have raw fuel go out. Because a 268 cam is like a 218 degrees at 50. It's a small camshaft. 218 or 220 or something. It's not very big. Are you on our poll? 66% and 34%. Still, 1/3, 1/3. That's 2/3, and then 1/3. I need to get the Omni back. I need to have some turbo in my life. And some turbo testing in my life. Got some shirt clingies. Oh, but we can go to live chat now. There we go. Victor, I wrote in, Brian Tooley had an LS7 with a Vortec on it. I think when I wrote in it, it only had a T or a TI trim, I think. Since then, it's been a few things have been done to it because I think somebody else owns it now, but I think it has a YSI on it and different heads or different cams. So it's just making a lot of power now. But I think that one's run on E85, I think. And it has water meth injection on it too, I think. But it would make a good roll race car, I'd say. NA drag race LS3 on the 85 with good heads. Is there a static and dynamic compression ratio you would aim for? No, I don't. I don't deal in dynamic compression ratio because it's not the only thing that affects. It's not the only thing that affects the detonation sensitivity. So a lot of guys want to think that that's the case, but it's not. And I don't ever. In fact, I've never even calculated on any motor that I've ever built. I don't think I've calculated dynamic compression, because it's not something that I look for. And so it's not something I aim for. I only ask because excessive valve overlap causes a bit of unburned fuel. Why do you think it does that? And on like I said, on a 268 cam, you don't have a bunch of overlap. In fact, you might not have any overlap. On a 114, you're probably not going to have any overlap. We can find out. We'll go to the Summit cam calculator. Cam timing calculator. And we'll put in 114. But I don't know what, I don't have my, let's see. A 218, 224, which would be close to what your cam is, I think, has negative 7 degrees of overlap. So you don't have any overlap. You have negative overlap on that camshaft. So how much would we have to go to get any overlap? Let's go to 110. If we went to a 110, we'd have 1 degree of overlap. But 1 degree of overlap is next to nothing. So you have to go fairly tight on a cam that small to get any overlap. And I don't think you have to worry about unburned fuel going out. Looking at the best option, twin GT35 6-liter stage 3, 6500, 850, best option for compression. What fuel are you using? Did you tell me that already? Ultimately you're playing with compression, which I think is the wrong way to do it. Your twin GT35 turbos are going to dictate how much power you make. They will tell you what the maximum is, irrespective of your static compression. They'll tell you how much power you can make because they're only going to flow so much. If you wanted to get absolutely everything out of them and you were trying to max them out and you were spinning them to their maximum impeller speed, and by that I mean breaking them, then I would run high compression. But if you wanted more power, I would just put bigger turbos on it. I also would not run a stage 3 camshaft for 6,500 RPM. I'd run a stage 1 or a 1.5 because an 850 horsepower is easy to do. I'd put a truck Norris in that thing with a truck intake manifold or a Trailblazer SS intake manifold. I don't know what heads you have on it. Even if you have 317s with a camshaft in, all of that works for those GT35s will do 1,000 horsepower. Getaway, what's up? Yeah, and on E85, you're fine. Are you looking to make them super responsive or something to try to make up for the fact that you have too big of a camshaft in there that's going to be soft down low? Obviously, I'm giving you a hard time. But yeah, I would put a smaller cam in it to get the turbos to come up, and guess what? They'll still make the 1,000 horsepower. Yeah, GT3582s are easily 1,000 horsepower turbos as twins. And as we know, twins are good. Richard, looks like I'm hearing more about MBE heads. I don't think I know that. I've never tested any. Brule may have done that. I'd have to ask him. Oh, so they make a lot of stuff. Small block Chevy, blown alcohol, small block Chevy 4,500 door spacing, top fuel. Wow. Block Ford, small block Ford, 5-inch bore spacing, big block Chevys, 4840 big block Chevys. Cool. I don't know anything about them. I've never even seen a pair that I can remember. Has anyone ever heard of a front sump big block Chevy set like an oil pan? That shouldn't be too hard to do, right? You just have to have a really long pickup for it because the pump's still going to be in the back. Have you seen any issues with the stock LS truck manifold and boost splitting or coming apart somehow? Not at any realistic boost level. And by realistic, I mean 25 pounds or 30 pounds. You'd be more apt to blow one apart like with a backfire, which that's been done. Nitrous backfires are not good. They're very explosive. And the pressure spike is instantaneous, so it's much more problematic. Could you please dyno test some of the heads? Yes, I'll just jump right on that with all of my big blocks and all of my contacts at MBE that I've never even heard of. Safe maximum RPM stock bottom end. We run junkyard motors. We've run them to 8,000 on the stock bottom end, so 7,000 is fine. 68 and 32 is 63 votes in. I've never run one 8,000 with boost. We did an 8,000 RPM deal, a stock bottom end 5.3, but not with boost. I'm told all of the experts tell me that having boost is easier because it's got pressure on the piston and stops the snatch load. That's what I'm told. So I wonder if the motors are coming apart. If they're not coming apart because of RPM, they're coming apart because of some other thing. None of the things that I put together need to make power out at 8,000 RPM, except for the one that we did as a dedicated one to see about the hydraulic roller going that high, which we knew that before we did it, but we knew that it could be done. People like to see big gee whiz numbers, for hydraulic roller stuff. And guys run there, but I think if I was doing that, 8,000 or 8,500, I'd start to think about solid roller stuff. What you can do and get away with and what you should do are sometimes different things. I've done a lot of stuff that we see if we can get away with it. And we do. But that doesn't mean that it worked, doesn't mean that it was right. You're upgrading your oiling system, a high volume pump, that counts, man. That totally counts. Or for like a small block Ford, or even a small block Chevy, the oil pump drive. If you put a heavy duty oil pump drive on it. Richard, have you ever tried testing a blower turbo motor with an off-the-shelf cam compared to a custom grind cam to see? Well, the word custom and the word off-the-shelf tell me nothing. So what I would look at is, if I was doing a cam test like that, first of all, the custom cam thing I don't think is a real thing. I mean, there are custom cams, but every shelf cam was a custom cam at one time. Every shelf cam had to make a first one at some time. So it was a one-off cam. So it was a custom cam. And then they tested it, hopefully, that you deal with people that test cams. And they tested it and it worked, and it becomes a good cam. So if you run, I can tell you I've run lots and lots of cams, and every cam that has 230, 231, 232 at 50 or whatever, they're all going to make really similar power. I would like to see somebody, they'd have to change the camshaft dramatically to have it change the power dramatically. And so then it would just be a different cam. It's not a custom, it's not a shelf, it's just a different cam. So we could pick a different shelf cam to make more power than the first shelf cam we picked. So the people's perception of a shelf cam and a custom cam are not the right perception. They should just look at them as two different cams. Could be two different shelf cams, two different custom cams, whatever. The guys that make camshafts want you to think that, oh, custom cam, that's up here. Shelf cam, that's down here. That's not the reality. That's not at all the reality. Have you ever dynoed a vacuum secondary carburetor and then switched it out for the same CFM double pumper to see what the difference is? I don't think I have. I can tell you on the engine dyno, one of the problems we have with vacuum secondary carbs is the vacuum secondary opening. In every instance that we've ever run a vacuum secondary carb on, we have to put the lightest spring in it to get it to work on the dyno. And we don't seem to see that same thing out on the street. So I don't know if it's a function of the dyno controlling the RPM or what's going on there. So I don't know that that's an ideal place to make that comparison. But if both of the carburetors had the same body and bore size and jetting and stuff, they should make the same power. The only thing that could happen is if the secondary didn't open up at the same rate as the mechanical secondary, then you might see something on the initial stab in, maybe. Didn't watch the video. What's the cheapest way to achieve a dry sump? To buy a dry sump. That's not something you want to go cheap on. Any of the shelf intake options for a 4.3 liter Chevy V6 with a forward-facing throttle body and port injection? The Marine one is the only one that I know of. A custom cam just maximizes the particular setup of the shelf cam. You put it in, hope for the best. I 100% disagree with that. That's the perception that's out there. That's what the cam guys want you to believe, that there is some sort of one cam to do. Like if you give them a combination, I've got this head and I've got this intake and I got this displacement and all that, that there's one cam that's the best cam for that combination. And that's 100% not true. I've tested way too many cams to know that. We could put one guy's custom cam in and it's going to do one thing. I could put another guy's custom cam in, and because the cam's different, he changes the lift, the duration, the lobe separation angle, just the things that you change in a cam, and it's going to be different. And neither one of them are going to be the best cam for that combination, because there isn't a best cam for that. And that's what people have a hard time understanding. Nobody out there can give you the best cam for that combination, because they could give you the best cam, but it's not going to be the same as me or anybody else that has that same combination, because what they want out of that combination isn't the same thing. So it's wholly subjective. That's my 2 cents. And that's a very common question. Richard, what's the best cam for my 5.3? Well, I don't know. I don't know what that is, because they believe that there is one that's above all the others, and it says custom on it. Apparently, that's 100% not the truth. I've used Melling high pressure stock volume LS oil pumps multiple times in builds over the years, and compared to a stock one, I do not see much difference, if any at all. Have you actually compared it? Like, have you taken the Melling high pressure stock volume LS oil pump and run it, and then taken that out on the same motor and run a stock pump and data log the oil pressure and temperature and all that to see if there is a difference? Custom grinds are experimental unless if you crunch the numbers for the heads, the valve springs. Even if you do all that, even if you put in absolutely every last speck of data that is even possible to have, and you build a camshaft, what happens if I change that camshaft by 1 degree on the LSA or the intake duration, or change it by 10 thousandths lift? What happens if you do that? Still a custom cam. Which one's better? What if one makes 2 more horsepower somewhere else and 2 less horsepower somewhere else? Which one of those is better? That's my point. That's what people aren't understanding about this. People want there to be, they think that somebody can put together a combination. Like, I could give you, okay, here's a, what is that GM crate motor? The B15 crate motor. Here's a B15. Give me the best cam for that. Well, where do you want your power? Are you running a blower? Are you running a turbo? What RPM range do you want? What are all the things? What is the best thing? And then even if we narrowed all that down, I'm going to run an LS3 intake manifold. I'm going to run a Pro Charger. I'm going to run it on E85. What's the best cam for that? Well, what plays are you running? How much RPM range? How much RPM are you running? Is this a street car? Is it a race car? What's your stall converter? What are all these things? And again, after somebody picks a camshaft for that, it's not going to be the best cam, no matter who makes it. Because if somebody likes it because it makes the most peak power, it's going to give up power down low. What if I want more power down low? Then my best perfect cam for that combination is different than somebody else's. And that's my point. That's what people don't understand. That's what you get when you've tested hundreds and hundreds and hundreds of camshafts. You look at it and go, oh, yeah, there's not an ideal cam, because I want that, and I want that, and I want that, except that there's no way to have all of that, because it's not possible. I built the 5.3 L33. Nice. I like the sound of a centrifugal blower. I like to build one, but make 800. I don't know what the word thoughts means, so I don't have any idea what your question is. Cletus McFarland dumpster fire cam 224, 228. Yeah, in my opinion, that's not a great camshaft. It doesn't have enough spread between the intake and exhaust. It's a pretty wide LSA. I don't know why they call it a dumpster fire. That camshaft should not have a lot of chop to it. A 224, 228 is not the cam that I would put together. A 224, 232 would make more power than that camshaft. Best cam is dependent on your needs. The best cam is wholly subjective. That's what you need to say. There's no best cam. That does not exist. Yeah, 4 cams with the same specs but ground on different lobe designs. Yeah, you can have different lobe profile. I mean, the lift, duration, and lobe separation angle. When I talk about those things, there are a lot more things that go into making a camshaft. But those are the 3 things that most people understand. But even if, like I said, even if the cam lobes were all the same and the base circle was the same, the the hardness of the cam, the finishing of the cam, if everything was exactly the same, which it's never going to be between different cam manufacturers, it's never going to be that. But even if they were, like I said, what if somebody wants a camshaft that makes 10 more horsepower at 4,000 RPM and is willing to give up 10 horsepower at 8,000 RPM? That's their ideal camshaft. Who's to say that they're not right? They are right because it's their thing. That's why there's no best camshaft. There is a best cam for your situation, for an individual, but not for a combination. It's like ACVWs, air-cooled VWs. They used to say, oh, you have to have a 110 cam. Yeah. They're specking cams by lobe separation angle. What is the 110 cam? Why were they calling it that? It's got a 108 lobe separation angle, so it's not that. Is that an intake centerline number or something? 247 at 50 on a VW cam? Isn't that a big cam for a VW? 68% and 32%. And we have 2 more minutes. I'm going to close out our poll. I got to get going. I got to get paid. That's my 2 cents on camshafts. I know the world wants to believe. It's like saying that there's a perfect intake or a perfect cylinder head. There's not. There is not. Back in the day, 112 LSA was the thing, and now it's a 110. That's another thing that I don't agree with. They've attached onto this LSA thing. Oh, why doesn't Comp or Brian Tooley or somebody, why don't they make tight LSA cams? They don't know what they're doing. They don't know anything about cams. Like, yeah. Brian Tooley's forgotten more about camshafts than these guys will ever know. And because they don't make a 106 LSA cam, they think that there's some sort of like internal conspiracy or something going on. It's just nonsense. People just do not understand the cam market. Maybe I need to do a video on that. The cam conspiracy. Victor, you can make 1,000 or 1,100 horsepower with just a blower. That's pretty easy. An F1A94 will do that. You won't need to spray it on top of it, although you can to get the thing going in the lower engine speeds. I need to do a camshaft conspiracy. The lobe separation angle conspiracy. It's all the people trying to keep us down, trying to keep us wide LSA'd. the big cam cartel. Oh, that would be good. I would love that. I never get to hear what the cams you test sound like. So you want idle clips then? I don't spend a lot of time idling the motors because I don't care about that. But I could do more idle stuff. Yep. Yep. It's because the cam companies don't know what they're doing. Oh, just all the silliness. I don't know why can't it be just a simple question? Hey, can you test a cam with 106 LSA? Yeah, we can. It's not going to fit in anything, and it's going to idle terribly, but we could do it and see how much power it makes. That would be a good thing, rather than you never run 106 cams or 105s or 102 or 98s or whatever. I've run some of the really tight ones like that, but you never do that. It's because it's not even my fault, which is nice this time. It's because of the cam companies don't know about lobe separation angle for some reason, despite the fact that they've been designing and testing cams for, I don't know, 30, 40, 50 years or whatever. It's never occurred to them to try a tight LSA like all of their short track cams are. It's never occurred to them to try any of those because they don't know anything about cams. That's why it's just laughable. I know you did an LSA test already, but can you do a 112, 110, 108? I already did that. A camspiracy, that needs to be a shirt, right? The LSA camspiracy. That would be a good title, all right? I think points for that. So we went from a 112 to a 108. The 110 would be in between those. So it's pretty easy to see that. You should be able to make that jump for yourself. That's pretty simple. Because I can't ask, hey, can we test 15 different camshafts? We had 4. And also there's limitations on the 4, because I think we went from 120, 116, 112, 108, I think. And I think that they had trouble getting all of those on the same blank, maybe, because their UGLs only have so much room. And I'm doing a video with Brian on UGLs because a lot of guys don't understand what that is. And I didn't understand it at the time either. So I get to be educated, which is that's always good to learn. And on that note, it is time to go. If you haven't, please go take a look at the oiling system mods on the small block Chevys, on the small block Fords, the 347 and the 427. And I will be back tomorrow. I'm trying to put everything together on the LT1 stuff on the 6.2 LT1. So all of you LS3 guys, be prepared to be angry. See you tomorrow. And we're ending.